by Kate Lanosa. According to the Merriam-Webster Dictionary, a vector is a quantity that has both size, also known as magnitude, and direction. So what is a vector exactly? So let's take two coordinates. I'm going to say this is 1, 2. And then over here, this coordinate is going to be 5, 6. There we go. A vector goes from one coordinate to another. So for instance, this vector, if we wanted to go from 1, 2 to 5, 6, would look like this. It would be a line with an arrow on the dot. And that is how our vector works. In order to write a vector, they tend to be written in brackets, and you subtract the x's, so x1 minus x2, and you subtract the y's, y1 minus y2. And that'll give you the equation for the vector. So for this one, for instance, so since we want two positive numbers because the vector is going in a diagonal upward direction, our 5 is going to be our x1, and our 1 is going to be our x2, and then our 6 is going to be our y1, and our 2 is going to be our y2. So now we can plug that in. So we have 5 minus 1 and 6 minus 2. And after doing simple subtraction, that comes out to 4 and 4. And that is the equation of our vector. To add vectors, you will put them point to tail. So this is what that would look like. So you would have one vector here and another vector here. And then the result of adding these two vectors together will be this vector here. So now let's say this blue went over 3 units and this black went up 4 units. Well, we already know this will be 5, but let's prove it. So we have, let's say this starts at the origin, so this is 0, 0. And then over here, it will be -3, 0. And then up here, it will be -3, 4. Okay? So this blue vector would be -3, 0. And this black vector would be 0, 4. To add the vectors, you add the x components and you add the y components. So this new green vector will be -3 plus 0 and 0 plus 4. And that would come out to -3, 4, and that is the equation of the green vector. Subtracting vectors is a very similar procedure to adding vectors. Instead of going from point to tail when we added vectors, this time we're going to do tail to tail. So this is one of our vectors, and this will be the other. So see how they're tail to tail? That's what we want. Now this third vector will be found by subtracting the black vector by the blue vector, and that'll give us this new vector, the green vector, which is what we're looking for. So let's give these a few labels. So let's call right here the origin, so that's 0, 0. And then I want to say that this blue vector is about 4 units, while this black vector is about 5 units. So then this point right here must be -4, 0. And this point must be -4, 5. So to subtract these vectors, we must subtract the black vector by the blue vector. So the black vector is 0, 0, 5. Let's make that a better bracket. While over here, this blue vector is -4, 0. So to subtract these, we subtract the x components, so 0 minus 4, and subtract the y components, so 5 minus 0, which will give us -4, 5, which shows that from -4, 5, we went down 4 and to the right 5 to get to the origin, which is 0, 0, which is the equation of the vector we're looking for. We can also find three-dimensional vectors. So let's draw a quick grid here. And this is a three-dimensional grid. This is our x, this is our y, and this is our z axes. Okay, so let's create two three-dimensional coordinates. So we have one coordinate which will be at the origin, so 0, 0, 0. And then let's have the second coordinate here be 1, 4, 3, and that's one of our vectors. The second vector that we want to do is let's have one at 4, 5, 9, and the other coordinate at 6, 2, 5. This vector will be vector A, and this vector will be vector B for our dot product. So let's graph these really quickly. So now that we have all that graphed out, let's find the equation of these vectors. So vector A will be 1, 4, 3, because it's going from the origin to that coordinate. And then vector B will be 2, -3, -4. Okay, so for the equation of dot product, we multiply two vectors against each other. So we have vector A times vector B, which, when expanded, is A1B1 plus A2B2 plus A3B3. Okay, so here on these vectors, the first in the bracket is our A, the second number in our bracket is our B, and the third number in our bracket is our C. So now how we would write this is 1 times 2 plus 4 times -3 plus 3 times -4, which comes out to -22, and that is the answer for the dot product between these two vectors. So now let's create a real-life scenario with vectors. So let's say this man named Jerry is this little aqua dot here, wants to walk across the street 50 meters and sit under a nice tree he sees, which is 2 meters out. So to get there in the shortest amount of time, Jerry should take this path. Now what is the vector equation for that? Let's set some coordinates. So this aqua dot will be our origin, so it starts at 0, 0, and over here, since he went to the right 50 across the street, that'll be 50, 0. Then he went up 2, so this blue dot here will be 50, 2. So this original 50 meters, the equation for that in vector form will be 50, 0, and the 2 meter will be 0, 2. So now we need to add these two vectors together in order to get our green vector. So we add the x components, so 50, 0, and then 0 plus 2, and we get 50, 2, and that is the equation of our green vector.
Thanks for watching!